Good Friday morning. Not Good Friday, but good morning on a Friday. That would be next week. That is actually Good Friday. I wanted to go over what we did in class because none of my recordings actually turned out. Um, Going over this first one, these are problems off the review sheet that you do have the ability to do, but there's little tricky things about them. So I wanted to show you the different things about it. Now, one thing that always works is graphing the sequences on Excel. So you're calculating the limit of the sequence. We can calculate the graph on Excel and definitely look at that. So let's look at this on Excel at the end of this PDF. And you can see that the formula is up here where it says square root of, so this business has been typed in and you can see how to type it in. You definitely need to practice that because we were a bit rusty when we came to class. And what we see looking at the table of data is that it looks like this thing is converging and flattening out at 0. So my conjecture is that the limit of the sequence is 0. Let's test this out analytically. Well, this is not exactly what I'm used to. First of all, I can combine this n squared and 2n squared to be 3n squared because it has a square root in it. So how do I do this? Well, how do I calculate the highest power? I use something I called engineering math, which is approximations upon approximations, which mathematicians usually don't do, but it gives us good insight. So if you look at square root of n squared plus 1, and I'm letting n go to infinity, well, n squared is going to be a very huge number, and I'm just adding 1 to it. So in comparison, I've got a really huge number plus a constant added to it. It's not really going to make, that constant's not going to make a difference. So really, as n gets really large, this expression over here is a lot like square root of n squared. But square root of n squared is n, and that's the power 1. So this top piece over there is kind of like n. So it's a sloppy way of thinking about mathematics, but it gives us good insights. On the bottom, however, I have a 3n squared, so that tells me that the highest power is actually n squared. It's the 2. So I'm going to go through and divide everything through by n squared. The bottom's okay, the n squareds cancel, and I get 3. The top is again a little tricky. I have a square root of this n squared plus 1, and I have this n squared on the bottom. How do I combine this or reduce, which is the next step? In the rubric, you always had reduce correctly. Well, I have to rephrase this n squared in terms of square roots. So I'm going to rewrite the n squared as the square root of n to the 4th, because n squared is really the square root of n to the 4th. And now I can put all of this under one radical. And that's how I handle it. Now I automatically split up the n squared plus 1 into, I call it backward common denominators. Usually you're supposed to combine these and you're back to this step. I split them apart because it's easier to see things and reduce. The n squared over n to the 4th becomes 1 over n squared, and the 1 over the n to the 4th stays 1 over the n to the 4th, and this, our big bottoms go to 0, and so we have 0 over 3, which is 0, which confirms what I just showed you using the graph. This second problem, you can also just directly graph. I actually initially just looked at this and said I could factor out an n and maybe use the log laws that says log of a times log of b is log of a plus b. But I found out quickly that it doesn't really factor, it doesn't cancel anything out, so it wasn't really helpful. And I put helpful here. So bad thing about writing things, you don't have spell check. But what is helpful is instead if I look at log of a minus log of b, the log law says that's log of a divided by b. That is helpful because now inside the log is an expression I know how to deal with. That's division by the highest power. So I would actually simplify this. But let's go look at the graph before we get started. At the end of the page, there's the graph. Notice this is how I put in the natural log of this expression that I have. Scroll it down and I see that it levels off, looks like again, it's 0. So we get this expression here inside. I'm going to analytically show that it looks like it's 0 as well. The highest power of the inside is n squared. So this is all routine to everybody in the class. We just divide through every term by n squared. So I'm left with this natural log of this expression. Now I let n go to infinity and I get this piece goes to 0 and this piece goes to 0. So I get big bottoms go to 0. We get natural log of 2 over 2, but that's natural log of 1. And in case you forget, type it on your calculator. Natural log of 1 is 0. So I get a match. So this number 3c I picked out because two things. I wanted to remind you how we used to find derivatives a long time ago where our x1 and y1 were expressions. So here in this case, x1 was x, y1 is 2 over x, because I just plug in x in for the y value into the x value, and x2 is a, and y2 is 2 over a, and we get that by plugging it into the formula, plugging a into the formula. I'm just reminding you the steps. So then over here, we calculate the slope, y2, because that is what the derivative is, it's the slope, minus y1 over x2 minus x1. So from the previous list, y2 was 2 over a, x2 was a, y1 was 2 over x, so I get this and I plug it into the formula. I just realized now that I had done y1 minus y2 over x1 minus x2, exactly the same thing. I'm allowed to do that because it doesn't matter as long as if y2 comes first on top, x2 has to come first on the bottom. If y1 comes first on the top, x1 has to come first on the bottom. So this gives me this expression, and when we had other material, we had to FOIL things out and subtract and reduce. It's the same thing here. I have to somehow algebraically manipulate this and simplify this. So the way we do that is we get a common denominator on the top two fractions and combine those fractions. This denominator here is missing an a, so I place it there, but I have to do this on bottom and top. This denominator over here is missing an x, so I put it there on bottom and top, and the bottom stays the same. So now I can combine these two fractions and I get this expression. And I'm getting a phone call, so I'm going to have to take that phone call in a second. But let me finish this problem first. Isn't it interesting how the cell phone interrupts our life? So now I get this expression up here. And now I have a fraction over a fraction. Although x minus a might not seem like a fraction, it's really x minus a over 1. And I have to invert the denominator and multiply. That's how we divide fractions. And it looks a lot more simple. Now a minus x over x minus a, in the beginning of the semester, we talked about this quite a bit. That's minus 1. So those cancel, and I'm left with minus 1 times whatever's left over, which is really the minus sign just goes on top, and I'm left with this. The very last step is to let a slide to x. So if I let a slide to x, I get this expression right here, which is minus 2 over x squared. So review, go back to the beginning of the semester and watch those videos. It's exactly the same work. I just kind of quickly did it here, but the work is all the same. And this is how you find the expression for slope. Number 6L, you're supposed to take the derivative of something that's more complex than we're used to. There's a cosine of a mess inside here. And anytime I see a square root in calculus, I write it as the expression raised to the 1/2. This expression has, I call this a bookkeeping problem because it really is, I'm still thinking about what kind of problem this is and why it's important, but it's what I tell Calc 1 students when they're getting ready for classes like PChem, where they need to keep track of expressions, messy expressions. This is what I call a bookkeeping problem. So the inner function here is x squared minus 1 to the 1/2. And the outer function is found by covering this inner function up by an x, by your thumb and replacing your thumb with an x. So I get the outer function's cosine x. The derivative of the outer is simple. It's minus sine x. It's simple if you know it because it comes from a table. It's not simple if you forgot it and you're sitting in the middle of a test. So go back and memorize those derivatives of log, derivative of e to the x, derivative of sine, derivative of cosine. You have to know those by heart, which for bio majors, it shouldn't be that hard because there's a lot of stuff you have to memorize. The derivative of the inner is nasty because notice here I have another chain rule. I have an x squared minus 1 here. And then if I cover up that, I get x to the 1/2. It's another chain rule. So taking the derivative of the inner requires extra work. So here I starred this, and here's my work for star. My inner in this case would be x squared minus 1. My outer is x to the 1/2. The derivative of the inner is 2x. The derivative of the outer is 1/2 x to the minus 1/2, which we know is 1 over 2 squared of x. And so the derivative for the starred piece is this thing right here, assembled. It's the derivative of the outer function with the inner plugged in for x times the derivative of the inner function. So we assemble. And now I go back to here, I can fill in this part that says another chain rule with the answer that I got with the second piece of work. So it's a bookkeeping thing. Here's the derivative of the inner. Plugged in, that's the work that I just did. And then I assemble my big original problem. Y prime is the derivative of the outer function with the inner plugged in times the derivative of the inner function, which was the starred piece that I just worked out. So it's messy, but not impossible. And what I've seen is students are often not used to seeing really messy things, and that's why this looks scary. But each of the pieces alone are not difficult. So this is why I put these on the the example review sheet so that you can practice it, but I'm not too bothered if you can't do a double chain rule. You still should not be afraid. I think that's what that kind of skill gives you. It gives you bravery to look at something and say, I have the courage to look at that, even if it's messy. Okay, this ends our preparation using the review sheets. I might post some more problems up here just so that you can see them worked out. You're certainly welcome to ask me questions and I'll post them as videos